Okay, so the following example will illustrate generation and load bidding in day-ahead market. Then the market derives the market clearing price for day-ahead market. Then if there is some congestion in the line, then it has to be relieved. So for that, whether adjustment bids are submitted by the GENCOs or not, that we have to check, and it has to be adjusted accordingly. So in the third stage, we have the adjustment bids. Then we have the hour-ahead market. After day-ahead market, we go to the hour-ahead market. Separate bidding is there in the hour-ahead market. Then supplemental energy bids are submitted for actual consumption and production, because we know that all these steps are, until the last step, all these steps are they are involved. I mean, in the prior to the actual market scenario. In the actual market scenario, we have metered measurements. So the metered measurements would be mostly, it would be deviated from the scheduled transactions. So for these deviations, we have to go for supplemental bids and exercise the supplemental bids accordingly. Now we take an example of a two-zone system. Here two zones are given, zone 1 and zone 2, connected by a line which is assumed to be lossless in this particular example, and the maximum power flow limit for this line is 80 megawatts. The GENCOs have 90 megawatts and 100 megawatts capacities respectively. GENCO 1 has 90 and GENCO 2 has 100. Then two distribution companies are there. DISCO 1 has DISCO 1 has 70 megawatts and DISCO 2 has 80 megawatts load demand. So based on this, they are going to bid in the day-ahead market initially. So the first phase is day-ahead market. Now you see bidding in day-ahead market. So for bidding in day-ahead market, you can see initially the DISCO bids are shown. For DISCO 1, in the price range 0 to 40, the demand is constant at 70 megawatts. Right. So first we are going to plot the individual DISCO bid curve for DISCO 1. Okay, individual demand curve for DISCO 1. So from 0 to, you can see here, from 0 to 40, there is no change in demand. It is at 70 megawatts itself. Now for DISCO 2, from 0 to $22.5, the demand is 80. Then from $22.5 to $30 range, the demand drops from 80 to 65 megawatts. Okay, so like that, from 30 to 35, it again remains at 65 megawatts itself. Then 35 to 37.5, 60. Then after that, it remains at 60 itself. So for DISCO 2 also, we have a separate demand curve. After getting the individual demand curves for DISCO 1 and DISCO 2, we will go for aggregated demand curve. Then we plot the individual supply curves for GENCOs 1 and 2. I mean, we do it separately. Then we derive the aggregated supply curve. Then we plot both the aggregated supply curve and aggregated demand curve on the same plot to get the intersection point, and thus derive the market clearing price. Okay, so now for DISCO 2, what's the range? Initially 0 to 22.5, 80 megawatts, right? You can see here, this is 0 point from 0 to 22.5, 80 megawatts, right? Now from 22.5, it is the price is increased to 30 and the demand is decreased from 80 to 65, right? So the price is increased to 30, right? From 22.5 to 30, there is an increase. This is 30. Okay, this is 30, and the load has decreased to 65, right? 65. Okay, then it remains at 65 till which point? Till 35, right? from 30 to 35, it remains at 65. So it remains at 65 itself. Then after that, what happens? After that, it goes from 35 to 37.5. The price goes from 35 to, this is 35. Okay, this point is 35, 35 to 37.5. When it goes to 37.5, again the load is decreased. 35 to 30, load is decreased to 60. Then it remains at 60. That is why we have a the last part is parallel to the vertical axis. So it remains at 60 itself when it reaches 40. So that is how we draw the individual demand curves for discos 1 and 2. Now we want to find the aggregated demand curve. So to find the aggregated demand curve, what we are going to do is we are just writing these prices in ascending order for including both the discos, right? So the first price is 0. For this price, there is a corresponding demand for disco 1 and there is a demand for disco 2, right? Now, what's the next price? Next price is 22.5, right? At 22.5, there is a demand for disco 1 and disco 2. Then the next is 30, then 35, then 37.5, then 40. So for each price, including both, we will write the prices in ascending order and we take each demand, that is demand of disco 1 and demand of disco 2. Then we add the demands of disco 1 and disco 2 to find the aggregated demand curve. Okay, so what about the demand at 0? Can somebody respond? What about the demand at 0 for disco 1 and disco 2 here?
70 and 80 megawatts.
150 megawatts.
150 megawatts, yeah. So here at 0 we have 70 and 80, that is 150 megawatts. Then when it goes to 22.5, for disco 1 there is no change till 40, right? It is still 70, so it is 70 itself here. Then what about at 22.5 here 80, right? So here also 80, so this is 150, right? So basically in the aggregated demand curve we have the demand 150, constant demand 150 in the range of 0 to 22.5. Okay, now we go from 22.5 to 30. What about the demand at 30? It is 65 here. Here again 70 itself, right? So 70 and 65, 135. Now again 35. This is always 70. This does not change. At 35, what happens here? At 35, this is 65. So here again 65, 135. Then 37.5, 60. It becomes 60 here. So this becomes total becomes 130. Then there is no change. So it remains at 130. Now we are going to draw the aggregated demand curve. The same way we are going to draw the aggregated demand curve. So basically we have here the price range. The first price range is initial price range is from 0 to 22.5 where the demand is constant at 150. Okay, so we start with 150 in the megawatt axis and 0 to 22.5. Right now from 22.5 where is the next price hike? The next price hike is at 30 and at 30 there is a decrease in demand, 15 megawatts decrease in demand. So that is what is shown here. There is a 15 megawatts decrease in demand. That is, it goes to 135, right? It goes to 135 and the price is hiked by, the price has gone from 22.5 to 30. Similarly, we draw the complete aggregated demand curve from here. Now we need the aggregated supply curve. For that we need the individual bids of GENCOs. Okay, so we go for that. GENCO 1 bids and GENCO 2 bids. So here from 0 to 19.99 range for GENCO 1, the supply is constant at 15, right? Then from 19.99 to 20, there is a very small hike in price, but there is a big increase in, there is a drastic increase in supply from 15 to 90, and then it remains constant at 90 when the price increases from 20 to 40. Similarly, we have here for GENCO 2 also. Okay, now when we draw the supply curve from 0 to 19.99 price, from 0 to 19.99, what's demand? It's 15, right? It's 15. It's 15. Okay, it's 15. Then what happens after that? From 19.99 to 20. So this is not, this part segment is not actually parallel to the horizontal axis. There is a small difference. This is not 90 degree. This is just above 90 degree. This angle. Okay, a small a bit slanting. This is okay. Then when it reaches 90, when it reaches 20, it is 90. The demand is 90, right? The demand is 90. Demand is 90. Then after that it remains constant until 40. Okay, so similarly we are drawing for Genco 2 also from 0 to 19.99, 0 itself, 0 megawatts. Then again there is a small slanting segment here from 19.99 to 20. So this part corresponds to $20 per megawatt hour, at which the load is 40. Then from 40 to 60, it goes to 60. At 60 the price is 35. Then from 60 to 100, at 100 the price is 40. Okay, so this is the these are the supply curves for Genco, the Gencos, and we now go for the aggregated supply curve. So can you write the aggregated supply table? Can you write the aggregated supply table? Please write down that. So what's the first value? 0, then 19.99, then 20, then 35, then 40, right? So at 35, suppose we have for all these values 0, 19.99, 20, for all these values in the table itself we have values for supply in megawatts for Genco 1 and Genco 2. What about 35? At 35, what is the supply for Genco 1? What is the supply for
90.
Genco 1?
90.
90 because in the full range it has 90 from 20 to 40. So this is 90, then this is 60, right? This is 60, then at 40 we have 90 and 100. Okay, so basically this is not 80. Okay, this is 100, that is why it is 190. This is wrong. So 190, so 190. So we have the aggregated supply curve. Using the aggregated supply and demand curve, we just plot it in the same price demand axis, and we get the intersection point to find the market clearing quantity and market clearing price. So the market clearing price becomes, here it is shown, the market clearing price becomes $27.5 per megawatt hour. See, if this is asked for exam, then you have to draw the plots with proper scale, otherwise you will not get the exact values of market clearing quantity and market clearing price. So you have to measure it using scale and you have to take it. Okay, now the market clearing quantity is 140 megawatts. So here you get 140 megawatts as market clearing quantity and 27.5 as the market clearing price. Now day ahead bidding and exercising the day ahead bidding. Now it comes to the exercise of day ahead bidding. That means we have 1 minute. Okay, now we are finding how the market clearing quantity is distributed among participants. Okay, now what about Disco 1 and Disco 2? What is the price now? 27.5. So at 27.5, what is the price for Disco 1 and what is the demand, the power demanded by Disco 1 and Disco 2, and what is the power supplied by Genco 1 and Genco 2? That we need to find out. Okay, so at 27.5, what happens here? You see here at 27.5, suppose here 27.5 is the price. Then what will happen? From Genco 1, what is the supply? From Genco 2, what is the supply? What is the market clearing quantity? Total market clearing quantity? 140, right? So that has to be distributed among Genco 1 and Genco 2 based on the price, right? So what is the supply from Genco 1? Can anybody?
90.
90 megawatt.
Because from 20 to 35, it should be 90. So let us 1 minute. It's not moving. It should be 90 megawatts. Then what about the supply from Genco 2 at 27.5? What's the remaining?
50 megawatt.
50 megawatts. Total is 140. And also we have a from 40 to 60, there is 20 megawatts hike. Here the price hike is 15. So at 27.5 means it is half of this price hike. That is 15 by 2 is 7.5. Here it is 20 by 2, it is 10. So 40 plus 10 is 50, right? By that also we can find. Otherwise we can directly take it also for 27.5. The remaining load demand is 50. 90 plus 50 is 140. So from Genco 1 it is 90 and from Genco 2 it is 50. Now what about Discos 1 and 2? What is the demand for Discos 1 and 2? From Discos 1 and 2 it is 70 and 70 because it's at 27.5. What is from the demand curve? Where is the aggregated demand curve? Here. At 27.5 what happens here? It is 70 here, right? Then this is 80 to 65, right? 80 to 65. So what happens at this particular point at 27.5? See, the remaining is 70, right? The remaining is 70. 70 plus 70 is 140. So you can directly take 140 or you can find from the slope also. If you have an accurate plot, then you can directly draw to the from that particular point of price to the quantity. So then you will get the for Disco 2, the demand for the corresponding price for Disco 2. Okay, so 70 plus 70. So in that case here you get both the distribution of demand and distribution of supply. So this is the schedule, right? This is the day ahead schedule. Now we have other time frames also. We are going nearer to the real time by going through the hour ahead schedule, then adjustment schedule. We go through all these things and we reach the real time for the metered measurements. Now we have 90 megawatts here, 50 megawatts here, 70 is the load demand for Disco 1 and 70 is the load demand for Disco 2. So what is the flow now? 90 megawatts, right? But what is the limit? 80 megawatts. So 10 megawatts increase is there, right? 10 megawatts violation is there for the line. So if the Gencos have submitted adjustment bids, then what should be done with Genco 1? How much should be reduced from Genco 1?
10 megawatts.
10 megawatts should be reduced from Genco 1, and from Genco 2 we need to increase that 10 megawatts. Of course we are assuming here a lossless line. Okay, so we have to increase 10 here. So for adjustment bids, if Genco 1 has submitted a decremental bid, see, for in adjustment bids Gencos can submit both incremental bid and decremental bid, or either of them. Okay, decremental bid means for adjustment they have to reduce it. Incremental bid means they have to increase. So here Genco 1 should have a decremental bid and Genco 2 should have an incremental bid. Okay, of course Genco 1 cannot have an incremental bid because its capacity is 90 megawatts and it has reached 90 megawatts, right? So in the adjustment bids there is no chance that they have submitted an incremental bid. So they must have a decremental bid. That is, of course, it's their discretion. Now for Genco 2, the capacity is 100. So it can have both decremental and incremental bid. Okay, that option is there. Now for congestion management. So we know that 90 is the actual flow, but 80 is the limit. Now only 50 megawatt is scheduled from Genco 2. So Genco may have both incremental and decremental bid. Let's fix the demand as scheduled. So Discos would not provide adjustment bids. That is, if Discos are not providing adjustment bids, or they can provide also, but here in this case they have not provided adjustment bids. So we are fixing the demand here. Now what is the adjustment bid? For 50 megawatts, Genco 1 has an adjustment bid of decrement bid of 26. They don't submit an incremental bid, And for Genco 2, they have both decremental and incremental bids. For decremental bid is 26 and incremental bid is 30. Okay, now what is a path flow violation? It is 10, right? From 1 to 2, the path flow violation is 10. So Genco 1 decreases its output by 10 megawatts at $26 per megawatt hour, right? Genco 1 decreases, that is decremental bit, okay, 10 megawatts at 26 per megawatt hour, and Genco 2 increases its output by 10 megawatts at $30 per megawatt hour. The incremental bit of Genco 2 is 30. Now you see here we have to find the zonal prices. How will you find the zonal prices? We will come to it. Before that, let's see the new schedule. So Genco 1, the new schedule is 80 megawatts. Genco 2, the new schedule is 60 megawatts. And for Disco 1, both are 70. It is unchanged, right? The demand is unchanged. Now, to find the zonal price, what we are going to do is the most expensive incremental bid and the cheapest decremental bid is selected in each zone to remove the congestion, determine the zonal prices. That means you can see here the decremental bid of Genco 1. What is decremental bid of Genco 1? Here only one decremental bid is there. So there is no need of comparison here to find the cheapest decremental bid. There is no comparison here. And also in zone 1, there is only one generator. If multiple generators are there and if they submit multiple decrement bids, then the cheapest decremental bid will be considered as the zonal price. Okay. Similarly, if multiple incremental bids are submitted by multiple generators at a particular zone itself, then the costliest incremental bid will be considered as the zonal price. Okay, so that is a guideline used in California market. So here what we are going to do is we are finding the zonal prices. So what about the zonal price of zone 1? It is $26 per megawatt hour. Only one Genco has given the bid here. Now what about zone 2? In zone 2, Genco 2 is only there, so definitely it is 30 per megawatt hour. If multiple Gencos are there, then this is the guideline. Okay. Now schedules after day ahead and zonal prices. So after deriving the zonal prices, now congestion is not there with respect to day ahead schedule, and we have zonal prices for settlement in day ahead market and day ahead adjustments. Now we can go for the next time frame, which is the hour ahead market. Okay. Now hour ahead market. Assume the bids provided by buyers are as shown in tables 2.9 and 2.10. So again, Discos 1 and 2 are again going to bid in hour ahead market. So normally we get a better idea when we move towards real time, and when reaching real time we have a quasi real time set points of the generator, because even if we do optimal energy management, suppose, or optimal dispatch, the economic dispatch at any point of time before the prior to the real time horizon, there could be deviations, right? So every deviation is adjusted with the help of adjustment bids or reserve bids, or it depends on the guidelines of the market. Here adjustment bids are used to relieve the congestion, and any unexpected thing is compensated using adjustment bids. So now we have a better idea. So these bids are more realistic. It should be more realistic to incorporate, to account for the deviations from the day ahead schedule. So here in the range of 0 to 40, the demand is constant at 5, right? For Disco 2 in the range of 0 to 27.5, the demand is constant at 15. From 27.5 to 35, the demand drastically decreases from 15 to 5, right? Then it remains at 5 itself in the range 35 to 40. So we again draw the separate demand curves for Discos 1 and 2. Then from that we draw the aggregated demand curve, and we are going for supply curve. But in the supply curve, in the hour ahead market, Genco 1 has not submitted any bid. Okay, Genco 2 has only submitted bids. So while drawing the separate supply curves, we have only supply curve of Genco 2. Okay, but demand curve, we have aggregated demand curve. And we draw both on the same plot and we find the market clearing price and market clearing quantity from here. The same way what we have done in the day ahead market, the same thing we are repeating here. Now we get the market clearing, new market clearing price as $32.5 per megawatt hour. Okay, 13.33 megawatts as market clearing quantity. Now, what about the distribution among discos 1 and 2? For this particular price, 32.5 per megawatt hour. What happens? Can you give it from here? The aggregated demand curve. So 32.5 is the market clearing price. Our head market clearing price. What should be the demand from disco 1 and disco 2? That you need to find out. So from disco 1, suppose if we have here you can see the aggregated demand is 10 only and 5 and 5. Here the range is 5 itself, right? Here the range is 15 to 5. So more than 5 can come from disco 2 and 5 can only come from disco 1. So 5 is the 5 megawatts goes to disco 1 and the remaining will go for disco 2. That means the total is 13.33, right? The total is 13.33. So 5 megawatts is 5 megawatts goes to disco 1 and 8.33 goes to disco 2. Okay, so that is a distribution among discos. Now for hour ahead schedules, what is happening now? Because here this has become 75. Earlier it was 70. After the adjustment bids to relieve congestions in the day ahead market, the disco 1 demand was 70. Now there is an increment of 5 megawatts. Here there is an increment of 13.33. But the total, no, not 13.33. Here it is. What was the amount here? Disco 2? 8.33. 8.33. Yeah, 8.33. So it was 75. Then 8.33 now is increased. So the total increase in Genco is 13.33. But we know that there cannot be any increase from Genco 1, right? This was 60. So the whole increase comes to the Genco 2. If there is an increase here, then the flow limit is violated. So Genco 2 is the stepping up its generation from 60 to 73.33. So this is the schedule after our head market. This is our head schedule. Okay. Now note that the flow in the line connecting both zones is 80 megawatts and no need for adjusting schedules again to relieve congestion because it does not exist. There is no problem of congestion here. So it does not exist. We showed final schedule of each participant in table 2.3 here. Now go through this carefully. Here what happens is for Genco 1, initially the day ahead schedule was 90. To relieve congestion, it backed down its generation by 10 megawatts. So 90 minus 10, now it is 80. Then there is no overhead adjustment for Genco 1 because if any increment is done, then the flow limit will violate. Then so the net is 80 now. 90 minus 10 is 80. Now for Genco 2, the day ahead schedule is 50, right? There is an adjustment for congestion relief. This is 10 megawatts adjustment. Then again, our head adjustment is 13.33. So 60 plus 13.33 gives 73.33. Now for Disco 1, it was 70. There was no adjustment in they had not submitted the adjustment bids, but our head adjustment was there. Our head bids were submitted. So 5 megawatts according to that market clearing price, 5 megawatts increase was there for Disco 1. So 75 is the net demand now. For Disco 2, 8.33 increase was there from 70. So now the net is 78.33. Now comes the real-time horizon. When it goes to real-time horizon, that means see what is the motivation here? We are trying our maximum to cope up with the real-time horizon from the schedule point of view itself, because when we are nearing the real-time horizon, we are getting better idea, and when we move through shorter time frames, we are trying to be with the real-time measurements, but definitely there will be some deviations. So we want to minimize the deviations. That is the extent of accuracy we are expecting from the planned schedules. Okay, now of course there is a deviation seen from the metered data. For DISCO 1, the final schedule is 75. DISCO 2, it is 78.33. But the metered amount for DISCO 1, see, metered amount applies for, see here, metered amount applies for load only, right? Because anyway, GENCOs are dispatchable here. In this case, we are considering GENCOs as dispatchable, or otherwise also we have backup generators. So from that side, we need not take a metered measurement. Unexpected thing is load change, right? So that is why we are looking for load change. So the actual load is only 72.5. That means there is a deviation of minus 2.5. Now the actual load demand for DISCO 2 is 85.83. So the deviation is plus 8.5. Now among the DISCOs itself, they can settle an amount, because here there is a load decrease. Here there is a load increase. So this released load can compensate this partially, this DISCO 2. So 8.5 minus 2.5 is the net deviation, right? So this should only come from the GENCOs, right? So the ISO, the independent system operator, should take care of the new dispatch, the change in dispatch of generators, so that the net deviation of 6 megawatts is compensated in real time. Okay, that is what is expected. Now, what happens here? In real time, the load is 6 megawatts over scheduled amount, which means that unbalance exists in the system, which in turn causes under frequency occurrence, right? There will be under frequency condition. The ISO is required to restore the frequency by providing extra generation that balances the 6 megawatts. Note that the DISCO 1's metered value is less than its final scheduled value. Minus 2.5 is the change, and here it is 8.5. For DISCO 2 it is 8.5. The net unbalance of 6 megawatts will be provided by a generator and managed by the ISO. The ISO may use different categories of energy resources available for real-time unbalance. One option is to use supplemental energy bits, where generators submit supplemental energy bits for real-time energy. So in here, the ISOs can utilize generators supplemental energy bit to feed the extra requirement, or to compensate the deviations. So here supplemental bits are given in table 2.15. So for 10 megawatts deviation, the maximum deviation that is possible from GENCO 1 is 10 megawatts, and from GENCO 2 also maximum deviation that can be provided is 10 megawatts at different incremental and decremental prices. The incremental price for GENCO 1 is $37 per megawatt hour, and the decremental price of GENCO 1 is $20 per megawatt hour. Similarly, for GENCO 2 also they have submitted supplemental energy bits. Okay, now how can this be compensated? Let's assume that GENCO 1 and GENCO 2 provided the ISO with supplemental bits. It is shown here. Since the incremental energy is required, ISO would not use GENCO 1, because see, GENCO 1's increment is not possible. What's the issue with GENCO 1's increment? Congestion. So that is not possible. So GENCO 2 can only be considered. So the ISO would ask GENCO 2 to increase its output by 6 megawatts, the net deviation at $38 per megawatt hour. So the increment for GENCO 2 is $38. So at $38 per megawatt hour at its incremental price. So this is so after everything, the final settlement we will show. Please see here. Here. So the day ahead schedule 70 megawatts for DISCO 1. Okay, initially it is DISCO 1. So DISCO 1, the demand was 70. So at 70, the zonal price for zone 2 was $30 per megawatt hour. So 70 megawatts at $30 per megawatt hour, in the sense 2,100 is the amount that has to be paid, right? So this is buying power. So paying amount. So the money is outflow and power is inflow. Okay. Now adjustment to relieve congestion. There was no change for DISCO 1, right? It was fixed, no change. So it is 0. Now overhead adjustment. Where has this come? Because there was an increase in 5 megawatts, right? There was an increase in 5 megawatt, and this happened at an incremental bit, right? So 32.5 is the incremental bit. See, what happened here is 5 megawatts increase I will show you. Let me show this. Okay, this one, DISCO 1, so an overhead adjustment was done using 5 megawatts. Now this 5 megawatts, from where it has come, that we have to see. At that amount only this will be settled, right? Because this amount basically goes to GENCO. So here you can see 75 and price was, where is the incremental and decremental bit submitted? Overhead schedules, right? Overhead schedules. $32.5, right? So the market clearing price is 32.5 here. So that is why that is what I was searching for that here. So this 5 megawatts, the overhead adjustment at $32.5 per megawatt hour. So this is the amount paid to the generator. So this is also buying power, but the money outflow is $162.5. Now there is an unbalance, right? Because of unbalance, the load until this particular time interval, this is going to be reduced. This is reduced to reduced by minus 2.5 megawatts, and this is settled at $38 per megawatt hour. This is also based on the incremental bid of the generator, because what happens here is minus 2.5 change is there for DISCO 1, right? Then 8.5 change is there for DISCO 2. Imbalance here you see 8.5, there is a change. So 8.5 minus 2.5, 6 is the total change and total increase that is expected from the generator. So at that 6 megawatts, at what amount the GENCO is giving, that particular amount has to be paid by the DISCO. Okay, so here it is 38. So minus 2.5 at 38. So here this is selling of power, because reduction in load in the sense it is similar to increase in generation. Right, so this is selling. So this is inflow of money and outflow of power. So this is $95. Now you take the total from here. So the actual consumption you can find 70 plus 5 minus 2.5. This is 72.5. Okay, not 62.5. This is 72.5. 72.5, and the money is 2167.5. Similarly, you can find for DISCO 2 also. So you are getting here 2693.725. So the amount, the outflow of money is 2693.725 for DISCO 2, and the outflow of money for DISCO 1 is 2167.5. Similarly for GENCO 1, what is done? Initially it was 90 megawatts. The zone GENCO 1 was connected to the zone 1, right? So zonal price at zone 1 is $26 per megawatt hour. So at $26 per megawatt hour, it is inflow of money, selling of energy, that is inflow of money is $2,340, right? Now adjustment to relieve congestion, again minus 10 megawatts. Again at the zonal price, it is the congestion is relieved, right? So this is buying of power, because reduction of generation. Reduction of generation is like, what happens? Reduction of generation means, so that amount is reduced from the previous amount, right? So that is outflow of money. So 260 is outflow, right? So 90 minus 10 is 80. So the actual production is only 80, right? So here 2340 minus 260. The total amount is 2080. That is received by the GENCO 1. Similarly, we can find for GENCO 2 also. This is 2461.225. But now the problem here is net megawatt of DISCOs. What is the net megawatt of DISCOs? This is 62. So this is 72.5, and this is 86.83. 72.5 plus 86.83, which gives 159.33 megawatts. So that should be equal to the net megawatt of GENCOs, because we have assumed a lossless system. So 80 megawatts plus 79.33, 80 megawatts plus 79.33, which gives 159.33. Now net payment by the DISCO, there is a difference. We can see a difference here. Net payment by the DISCO is 2167 plus 2693. 2167 plus this is wrong, I think 2856 is given here. You have to total it properly, because a lot of errors are there in this particular textbook. You might have seen in the reserve management problem itself, the amount in dollars, some errors are there that you have to replace. If you are writing notes, then you can replace it. That is better. So here the total amount is 4861.225 net payment to buy the discos, and the net payment to Gencos is 4541.225. So you can see here there is a difference, right? The net amount paid by the discos, the full amount has not gone to the Gencos. This is the amount received by the Gencos. So there is a difference. The difference is $320. The difference is $320. So this is a congestion charge. The congestion charge should go to the owner of the path or the owner of the infrastructure. Who owns the infrastructure? So in different market scenarios or different market frameworks, the owner of the path is different. If suppose ISO is the owner, independent system operator is the owner, then this amount will go to the ISO. This difference amount will go to the ISO. Okay. So that is what is happening here. The money flow is shown in figure 2.15. Note that the congestion charges are equal to the congestion charges. How will you find the congestion charge? The other approach to find the congestion charge is equal to the flow in the path after congestion management times the difference of energy prices between the two zones. What is a zonal 1 price? What is a zonal 1 price? Here. $26, here $30. So the difference in zonal price is 30 minus 26, and which is multiplied with the flow, right? So 30 minus 26 is 4. 4 into 80 is 320. That is what is paid to the ISO, $320. That is the difference we have seen in the net payment. Okay, that is the difference we have seen in the net payment.